Okay, we'll start here.
Diagram shows particles in equivalent as forces shown by resolving horizontally and vertically from magnitude of the forces P and Q. Okay. We have P and 30 degrees and 4 and 12 degrees. And then Q. So we've got P sine 30 and P cos 30. 4 sine 45 and 4 cos 45. So if we do so 4 sine 45 and P sine 30, does that equal Q?
Yep.
And then 4 cos 45 equals P cos 30.
Yeah.
So P equals 4 cos 45 over cos 30.
Yeah.
So P equals
I think it'll give us a nice answer.
4 root 6 over 3, which is 3 point. What did you say? 3 significant figures?
Just anything?
Okay, so P equals 3.27. Then you substitute that back into the other one. So Q equals Q equals 4.46.
3.27, 4.46. And did you use the answer key?
Yeah.
3.27. Q is 4.46. They did a different method. Let's not bother.
Okay.
Okay, how about this one?
Hang on. Okay, so that's 30, Does that make... what's the question? Oh, find the magnitude of the force P and the size of angle A. So if that's 30, then this angle, and then, are we assuming that's the right angle or not? We're allowed to do that. We're not allowed to do that, are we?
Assume what's the right angle?
The other side of that triangle. Oh, that's...
this one?
We're allowed to do that?
Yeah, I believe it is.
Okay. So then that angle there is... $60.
Yeah.
So does that make A 60?
Definitely not.
Oh, damn it. Okay, so that part before it, that's the right angle there, isn't it?
Up here?
Yeah.
Yeah. That's x-axis, y-axis.
And then I can't see any rules. I feel like I need to resolve. I'm just going to do the P part first. So angles going... shall we do perpendicular and parallel?
Yeah.
Okay, so all the parallel ones, we have PN. PN's not going parallel. Damn. I don't know.
So usually what you do is resolve in the x direction and then resolve in the y direction. So resolve in the x direction, what do you
get? P cos A and then we have -8 cos 30. No, yes, no.
Maybe. It's either 30 or 60. Okay, keep going.
Equals 0 or no?
There's got this 5 force that, so the 2 is perpendicular to x, so that won't affect it.
What? What? What?
The 5 force?
Do you have to do that one?
Yeah, because if it was like that, if it was, you know, perpendicular, then it would be 0, but it's not.
So minus cos 30 minus 5 cos 60. I thought this is all wrong, but okay.
Equals?
0.
So I'll check 8 cos 30 as p cos alpha minus 8 minus 5 sine 30. Sine 30 is sine 6, that same thing. Yeah, no. It's just 8 because it's perpendicular.
Okay.
Because it's the exact opposite direction of the x-axis.
P cos A minus 8 minus 5 cos 60 equals 0. So P cos A equals 8 plus 5 cos 60. Yeah. And then I don't know.
We
Then
resolve.
we do the other one.
Sorry?
Then we resolve the other way.
Yeah, we've got two unknowns, so we can't solve it. So I'll resolve in the y direction.
P sine A plus 2
Mm-hmm.
minus 5 sine 60
Yeah.
equals 0. So P sine A equals 2 plus 5 sine 60. To get rid of the P, you have to I bet you have to minus 2 equations, but then how does that one work out?
5 cos 60. Any other ideas?
Well, those both produce constants, but then I feel like we should leave it in that format until we know what to do. I probably need to work out the angle.
How would you do that?
Yeah, so I've got 1690.
You've got simultaneous equations. Two equations, two unknowns.
Yeah, but the part. Okay.
How can you eliminate the p?
Minus them.
That won't eliminate it.
Divide it
Correct.
by what? Divide them by each other. So tan alpha equals
A bunch of stuff.
whatever that is. Oh, you can do it, or should I do it? You can do it.
Why don't we both do it?
Okay.
Cos 60. And I actually paid for this calculator thing finally.
Did you?
Yeah.
That's sad.
I'm a pro now.
This calculator's at 80 quid.
Which one's? Graphical?
The graphical one, yeah.
I'm not that rich.
That's 8.932.
Did you get 1 over 21?
I did not get to 1 over 21. Then again, I didn't do it in a nice format, so do you know what I mean?
Okay.
So hang on, let's just see if we get the same thing, and then I'll see whether I just.
I'm in degrees.
Sure. I'm gonna do it in the proper format now.
Did you inverse tan it? Oh no. Yeah, it's
What?
I'm in degrees. Is that different?
I don't want to be in degrees. What's the answer? It's a bit blurry.
Yeah, what was my previous one? Shift number 4. Let's take a look. Divide equation 2 by equation 1, you get 5 cos 30 minus 2, so that's... What did they do? 5 cos 30 minus 2, 5 sine 60 minus 2, same thing. 8 plus 5 sine 30, 8 plus 5 cos 60, same thing.
Your answer?
They got 0.222, and then they did...
As the angle?
No, and then they did inverse tan and got 12.5 degrees.
Yeah.
Is that what you got?
Yeah.
Okay. What's next?
Then you put that into the equation and then rearrange it to find P.
So what's P then?
That's 5 times 60 divided by sine 12. That doesn't look right. I'm going to do it in the fraction way because I always get an accurate thing with the fraction way. So 2 plus 5 sine 60 over sine 12. Oh, wait, no. What did I just work out? Oh, A, yeah. 29.2 I got.
29.2 newtons. No, I got something else.
That's exactly what I just did. I put it into that equation. Why am I getting 12? P sine 12.5 equals 5 cos 30. Let me try it again. 5 sine 60 and 5 cos 30 are the same thing.
Yeah. I just tested it for my own sanity. I'm going to do it their way.
I did it that way. I just didn't really get it.
5 cos 30 minus 2 over sine
12.5. Ooh, actually. Oh, I see where I've gone wrong.
Alright.
What was it, 10.8?
Yeah.
Yeah, I got it.
Okay, any questions there?
No.
Big picture, resolving the x direction to, resolving the x direction, resolving the y direction, and doing that kind of eliminates some stuff. And you end up with simultaneous equations, and then you solve them by dividing. That eliminates the coefficient. Okay. There's extra practice here if you want it. Do you feel like you want extra practice?
Maybe E.
Okay, yeah, good idea. So,
Because it's going a different, or C, depending whichever you want to do.
why did you say C?
Because no, the arrow going in kind of confused me a bit. Does that remember? It's just mean going down.
Okay. 1 second. Let's do C. Okay, how do we do it?
I don't know, that's where I was. I like drawing these one out. It makes them look really like mathematical.
Yeah, I feel that way about integration.
Yeah.
All the loops and stuff.
I hate drawing those loops though. I know they're only S's, but they're so annoying. I did that so wrong and I just draw it again. Also, you know, there's show me questions. I like those ones. Where oh my god, like the trigonometric equations, where you have to get it from one to the other, and you want to see how they got it to that.
You actually like those?
I like it. It just makes it look really cool.
All right.
Especially when you actually get the answer, which is a very rare case. But how do you draw that? Okay, so that goes up, and then that goes straight down. 6, and then that one goes in. That's 2n. P N and QN. X, Y. And then draw the little triangles. So that's 60 there. So that makes that 6 sine 60 and 6 cos 60. And then what else? What angle is that? What angle is okay? If you make the 2n one a triangle.
Like that, is it?
No, do that 2n.
Yeah.
If you draw a line from the end of it going down.
Right.
No. You want to make it the hypotenuse. Don't you? Do you know what I mean?
No.
Oh, is that the I don't know what that is. I was really confusing me.
So what you can do is instead of doing it in, you can just do it like that. It's the same thing.
Why?
So it's still pushing it to the right.
So draw it like that. That's 2n. So then what angle are there?
So let's do what angles. Okay, so what angle is, let's say this one.
What? Okay, let's just go normally and then if we get stuck, we'll get stuck.
Right.
So do in the x direction. We have it's quite confusing. So we ignore Q because that goes straight through it. Don't we?
In the x direction?
Yeah.
So in what sense do you ignore Q?
When it goes straight through it.
In that case, you ignore P because it's perpendicular. For Q, it will be neither cos nor sine. It will just be Q because it's going in that exact direction.
Okay, so Q minus 6 sine 60.
And say so Q.
If you make that 6 a triangle.
6 sine 60.
What else is going horizontally? Is there anything else going horizontally? Oh, in the x direction.
The 2.
Is it? So I can't see it. I can't see that too.
Is it not on your screen? No?
I can see it. I can't. How is it going? Yeah, but that's going like straight across. Not.
So it's not in the x direction, but it will affect. It's not perpendicular to the x-axis, so it's going to affect it.
So do you have to draw a triangle? Have you draw? I don't get it.
So let's say this angle in here. So that's 30 degrees. This angle up here.
Where? Oh, it's a bit baggy. Okay, that's 30 degrees. I can see that.
And so this angle here.
That's 60.
So you can use that with your 2.
Okay. That's 60. So then 2 cos 60.
Where were we? 2 cos 60. Okay. Plus or minus?
It's going plus.
Yeah.
Equals 0. So Q equals 6 sine 60 minus 2 cos 60, which we get 4.20. Yeah. Just no. 7, 8. Do you know what question it was?
I think it was 1C. Oh, 3C. Sorry.
3.
So 3C. Q plus 2 cos 60 minus 6 sine 60 equals 0. Let me see. Oh, where are we?
Oh, it's Q plus 6 sine 60 minus 2 cos 0. Cos 60.
No, we're correct.
No, we're not. The signs are different.
We have them in the opposite order, but it's correct. Q, they have as Q plus 2 cos 60 minus 6 sine 60. We have it as Q minus 6 sine 60 plus 2 cos 60. So it's correct. So what was Q, sorry? 4.20?
Oh, yeah.
Yeah.
Oh, thank God. And then, for the y direction, we have, my diagram's such a mess I can barely see anything. Oh, look at yours. P minus 6 cos 60 minus 6. Oh wait, no, not minus 6, I just did that. Oh. What else is there? Is that it for vertical?
What about the 2 force? Because that's not perpendicular.
2 sine 60.
Yeah.
Hang on. So P minus 6 cos 60 minus 2 sine 60 equals 0. P equals 6 cos 60 plus 2 sine 60. Right. What's the answer?
You tell me.
I hope people do that this time. No, I don't want. No, that doesn't look right. Hang on. At 4.73.
Where was this one? 4.73? Yep.
Yeah.
4.73 newtons. Any questions about those?
No.
Okay, you're good. And what might help is if you break it down to this kind of way of looking at it. So we were looking at the x direction. I did 2, and so 6 in the x direction. That was 6.
Where's your 2?
Sine 60. 6 cos 60. So 2 is here. So you see the 2. I just broke it down to, well, in the x direction it's 2 cos 60, and in the y direction it's 2 sin 60. The 6 in the x direction it's 6 sin 60, and in the y direction it's 6 cos 60. So I just broke it down to be everything perpendicular to each other.
Okay.
And maybe that will make it clearer when when you're doing these diagram things. Static particles.
Oh, is that what it's called?
Yeah.
Yeah, tick.
Okay. Modeling with statics. Let's try it. So you're now applying it to stuff.
Static particle. Is that what it's called?
Yeah.
I did not know that.
So the chapter is, whatever it was, application of forces.
I got the book. So I've got the answer. But I won't look at it. A series beadwise threaded on a light inextensible string. So you've got a triangle with a little circle, and then we've got and then that connects, and then we have that as a right angle. That's 30 degrees, and then we have force going left 8n. The end of the strings are attached to fixed points x and z. The bead is held in equilibrium by a horizontal force acting parallel to bead y vertically below x and x was find the tension in the string. So tension, there's one arrow going towards, like from the x going that way.
That is it? Oh, sorry, like that is it?
Is that tension? I thought tension was that the other way. Like a little, like a, I don't know if you can see that.
Like out on it? Okay.
Yeah. So label that T, and then there's another one. T. So does X and Z, do they have reaction forces?
Not sure. We have to find the tension in the string and the weight of the bead. So it's here.
Okay, we're going to do it that way. So 8 going that way. Up is tension. Down is weight. And diagonal is Z. What's Z? Just Z.
Yeah.
I won't draw like right there, it's more like diagonal.
Okay.
And then guess you gotta just start going for it, I guess. Then that's 30 degrees there. So then if we make some right angles, if that's 30 degrees, then that part is 30 degrees. So we have Z sine 30 and Z cos 30, and that's W, that's T, that's 8. Yeah, I don't know what I've got so far. Where have you got the answer?
So I don't know if this is the best way to do it, but
That's what I've got so far. You can't see it.
I can mostly see it. Hang on.
I've literally just got a right angle for the. I basically drawn a triangle for the Z part. That's literally it.
Okay.
And then we have this line here is t cos 30, and that one is t sine 30. What's the actual question? Find tangent. Oh, it's find the tension. Duh. So t cos 30
Mm-hmm.
equals 8. No, because there's also z cos 30.
That is the t, isn't it?
Is t z?
So you've got this one here is like t cos 30,
Mm-hmm.
and then this one is t sine 30.
Mm-hmm.
So t cos 30 is equal to 8 because this is
Yeah.
perpendicular.
T cos 30 is, yeah. So t equals 8 divided by cos 30. I got 9.24. Is that the answer?
I'm sure it is.
No. Yeah.
Yeah. Okay. And it's actually just one string, so it's just one tension.
Yeah.
And the
The
weight
weight
of the thing.
W equals t sine 30, and then put the t in, and then you find W.
Don't forget, it's going to be weight times gravity.
Yeah.
Because it's newtons.
So t sine 30 equals WG. So t is 9.24 sine 30 divided by 9.8 equals W. So 9.24 sine 30 divided by 9.8. Oh, that does not work out. Wow.
What do you mean?
I've just got a really weird number. Let me try it without the 9.8 and see what we get. 9.24 sine 30 minus WG so 9.24 sine 30 divided by 9.8. What's the answer? 13.9.
Where are we going wrong here?
There's some next level stuff.
Resolving upwards.
They've got T, there's two T's in there.
I just deleted my second t. They snaked me. Snake man.
Snake.
I thought I must be wrong about that. Yeah. So we've got the tension in this string, and then the vertical component of the tension in the diagonal string.
So we've got T and T, so T plus T, no, T sine 30 plus T minus WG.
Yeah.
And then, work that out, and then you should get an answer. I can't believe.
So it's on the top. There should be an extra 9.24, is it?
Yeah.
4. Because there's two strings. 1.4.
No. T sine 30 plus 9.24.
Sure. No, they didn't do G. Oh,
It's a
sorry.
Newton.
Sorry, they just want weight.
Yeah.
They don't want the force. Yeah, we're working at the force, but they just want weight. Okay. Okay. Hang on. Just delete the bottom.
Try it now.
13 point.
13.9,
Yeah, okay. Any questions with that one?
No.
So I think, yeah, doing it this way helps, and you can see tension doesn't go down, it goes up. Right.
Ew, I just do. Okay, you're gonna have to draw this because I really don't think I can be bothered.
The pulley, is it?
Yeah, I just hate drawing. So we have one, and it goes over and around the pulley and hangs freely like so. And then we have force going into chord P. Angle is 45 degrees. Okay, so we have tension and tension. We have. Does it tell you what they weigh, or is that not? So there's 3 kg and 1 kg. So this is 1g and that one's 3. So put those forces on. Then we have a reaction force that goes perpendicular to the thing.
Right.
Okay, so if we're taking up and right as positive, so if we do, okay, whatever, do a little triangle here. So we have, that's 45 degrees. So we have 1g sine the 45 and 1g cos 45. So if we do, I still don't know how to really do the p, to be fair.
So you can do P like it's being pulled away from it. And it's the same thing.
So okay, so if we do x direction, so parallel, we have t minus 1g sine 45 plus p how do you know? How do you actually know?
P is going to the right.
Yeah.
And so it's gonna, if we're resolving in the x direction, it's gonna have an x component and a y component.
Yeah.
So what are they?
So the x one's cos
Sure.
45 equals 0. And then in perpendicular, so up and down, y direction, we have shall we do the 1 kg one first and then do the damn it. We fucked. That one's 3 kg. So it's 3g sine 45.
So this is this.
So we're doing the 3 kg one first and resolving perpendicularly and parallel, and then we'll do the 1 kg one separately, because that's got like 2 things. Actually, it'd be quicker to do the 1 kg one first. Right, 1 kg, resolving down as positive. So 1g minus t equals 0, t equals 1g, t equals 1.8. Then you put that into this equation, because t minus 3g sine 45, okay, p cos 45 equals 3g sine 45 minus 9.8. So P equals 3g sine 45 minus 9.8 over cos 45. P equals, I mean, you could cancel that out, but I just don't want to do anything just in case. Minus 9.8 divided by cos 45. P equals 15.5.
15.5, 16 they rounded it to? Yep.
Yeah. And the perpendicular, what's the actual question?
Find P, was it? The magnitude of P. The normal reaction between the mass.
So that's just like the perpendicular. So perpendicular we have r minus 3g cos 45. So r minus 3g cos 45 minus p sine 45 equals 0. R equals 3g cos 45 plus p, which is 16. 16 sine 45. R equals 3, 9.8. Plus 16 sine 45. Oh, 32.1.
32.1. 32 they said. And part C states how you have used the assumption that the pulley is smooth in your calculations.
Tensions are equal.
I don't think so.
For smooth?
Yeah.
No friction?
Yes, there's no friction and so there's no counterforce. The pulley is smooth, so the tension in the string will be the same on both sides of the pulley. Ah.
So that's right. Tension will be the same.
Tension is on both sides. I think we said the same thing.
You said friction.
So it would stop being the same if there's friction on both
Isn't
sides.
that for like when it's a rough surface, then you say there's friction?
Yeah, and then there's like an extra force going the other way. But if that's the way they want it, then that's the way we do it.
Sorry.
Let's take a look. Wow, so many. Okay, we'll do one exam question.
One.
Well, there's like 6 of them or something.
Okay, so we have B. Then we have 2n. Then we have A. And then we have a dotted line. And C. And there's 30 degrees. That's a right angle. That's 60 degrees. Smooth bead is threaded on a light and extensible string. Center of the string attached to fixed points A and C. Bead is held in equilibrium by a horizontal force of magnitude Qn acting parallel to C and A. Parallel to CA. Find the tension string. And this is like the one we did a second ago, but like I still don't know how to do that. So we have tension going up. And tension going that way up as well.
Right.
So we have T sine 30 and T cos 30.
Okay.
Oh yeah, we have weight as well. And we have 2n going that way. T2 sine 30 and T2 cos 30, and then just T.
This one is going diagonal. This one is going diagonally, so it's going to have a vertical component and a horizontal component.
T cos 60. T cos 60 and T sine 60.
Which is which?
That one there
Going
is...
up?
Yeah, that's T cos.
I think that's T sine 60.
Why?
So this angle here is also 60? Right.
Oh yeah. Yeah, that makes sense. So T sine 60 and T cos 60. And then the tension is... So if we do 2 over cos 30 equals tension, because T2 cos 30 minus 2n gives you 0.
Don't we also have T cos 60?
Damn it, why did I do that? Even though I've drawn it, it still doesn't appear. Okay, hang on. Okay, 2 plus, no, I'll do it that way. T2 cos 30 minus T1 cos 60 minus 2 equals 0.
And I believe the T's are the same. That's just T. It's the same T.
Yeah. So T cos 30 minus T cos 60 equals 2. And then I got T cos 30 minus T cos 60
Yeah.
equals 2.
Cos 30 and cos 60 are just numbers?
Cos 30 is root 3 over 2. So root 3 over 2 T minus half T equals 2. Take a factor of T out. So we get root 3 over 2 minus a half equals 2. T equals 2 over minus T equals 5.46.
Okay. B, mass of the bead.
T160. I'm just going to do T60. T sine 60, sorry. plus t sine 30 equals, oh no, minus w equals, so it's equal w. So substitute the t in, so you get 5.46 60 plus 5.46 sine 30. W equals 7.46 or 7.5, depending what you round it to.
Okay. And then state how you have used the modelling assumption the bead is smooth in your calculations.
Tension same.
Tension on both sides. This is question 5, part B, I think. Uh, 5.46 for A, and then B, I knew it. You have to divide by G. 0.76, because you divide it by G. It's because the last time they asked for weight, this time they asked for mass.
Oh, okay.
And force equals mass times acceleration. And so the force going the other way, like the mass is going to be the force going the other way divided by acceleration, which is G.
0.76.
Yeah. So that's the weight. So
kg.
Kilos, yeah.
Or N. So mass is kg, weight is N.
Yeah. No, well, I don't know about, no. Force is newtons, is N.
So weight is weight the force?
Weight is weight. It's in grams or kilograms or whatever.
So what's mass?
Mass is also in grams. Don't listen to me. What do I know? Modeling with statics.
Tick.
Okay, so what did we not get to? Probably loads of stuff. Question. Yeah, got them fashionable. C, D, E, F. Okay, we got 2 sections out of it. How is that for Saba?
It's good.
Anything in particular you want to do next time? Do you want to continue this or something different?
Yeah, just like the harder ones. Connected particles?
Is that friction and static particles? Connected particles?
Yeah, frictions, yeah.
Okay. Like, continue this chapter, is it?
Yeah.
Okay.
Probably.
Any questions for me in general?
No, thank you.
Alright, well then Saba, you did great. I look forward to chatting again next week.
Thank you.
Alright, have a good week. Goodbye.